Hi, welcome to Chem 1LD. In the first experiment, you will study Mantle's freezing depression coefficient. To do that, you need to have a really good cooling curve from the measurement. To do that, we have set up like this. This is going to be a similar style setup of yours in Astrolat. We have a hot plate. And we have warm bath, which is water, and we can see that it's just warm. You don't need to be make the water boiling because the mantle's melting point is not that high. It is basically 36 degrees. So as long as the warm water right now, I'm looking at a 55 degree. That's totally fine. And we have our ice bath. You put more ice than water in your ice bath to make the temperature difference from the warm bath to ice bath more dramatically, so you can distinguish your phases in your cooling curve much better, right? And then you have your mantle. My mantle already melted, right? I have the temperature probe in here, and the temperature probe is directly connected in my lab device, channel 1. And the tube is clamped on this fan, which is attached to this laboratory stand, makes it more stable when you try to melt it. And it's much safer, because I did see people drop the entire thing into this warm bath before, so might as well just go everywhere. So for this lab, we have two safety concerns. First, you do have this hot plate, right? And also do not touch the hot plate like this because it is hot. I do that because it's old habit that I was working at McDonald's. We try the grill, see what kind of food we can cook. Anyway, so don't touch the hot plate, and also we have cables. This is hot plate cable. This is the temperature probe cable. Those are surrounded or wrapped around by rubber, right? So if the rubber touches hot plates, you won't be damaged. Second safety concern will be mantle itself. Even though you see mantle in your daily life, however, this mantle is kind of pure mantle. So if you have a really good sniff on this mantle solvent or liquefied mantle, it will make you uncomfortable. By the way, I think the mantle is one chemical that you should be looking at. So what kind of safety word for mantle? You should know by now, right? And to do this, basically we have two things that we need to worry about, right? One is how you do it, and the other one is the technique. So basically, I see a lot of students that start collecting data when the temperature probe was outside this mantle. So the first reading basically is room temperature. And then it's kind of confusing because the temperature jumping around from low to high and to low again. So that's something that you can avoid by just putting the temperature probe inside this mantle, like what I'm doing right now. So the first reading will be the mantle, and second will be you need to have this up and down motion, because some people just leave the probe like this inside the mantle through the whole process, and that will cause you to only read that one point, which might make it inaccurate. So what our purpose is that we want to have a really good reading of the temperature change in mantle. So with this up-down motion, you can actually obtain more data through the mantle sample. And of course, another safety concern that I forgot to mention is the glassware, right? There's always a possibility that you're broken glasses. If you do broken glasses, please contact or let your TA know immediately so he can or she can clean up. Alright, so let's give a try, shall we? So for this experiment, we're going to use a time-based mode. What I like to have is 5 seconds per sample, which can have somewhat distinguished, and also you have to have so many data to sort. And also my duration is 300 seconds, which is 5 minutes. Usually 3 minutes or 180 seconds is it should be good enough, but just to be safe. Because after we think our data is good, we can just stop anytime we want, right? So just to be safe side, I'm just gonna set like 300 seconds, which is a 5 minute. All right, so now we're going to collect. When I was collecting, I like to look at our graph to make sure that the cooling curve is as expected. All right, let's start. So by clicking this green button right here, the collecting will begin. Here we go. See? When I move this mental example from the warm bath to cold bath, right? My motion, which is upside down motion, never stops. And right now, you can see the temperature actually decreasing quite dramatic. And I can start feeling some stickiness on the tip of my finger. What do you think that will be? The stickiness actually getting stronger. Alright, so right now we're 50 seconds in. The dropping of temperature become nicer, significant, or right now it's actually leveling, right? You can see the temperature is leveling, not drop anymore. Why that is? Alright, so you can see the temperature actually dropping again. Also, I felt that the temperature probe just keep pounding on kind of hard plastic kind of feeling. Why that is? Alright, so right now it's 120 seconds in. The temperature was dropping pretty stable, right? And also you can see that our example is basically all solid now. So since right now it's all solid, we can just leave it be like this. And at this point, at 140 seconds, you can finish your collection if you would like to. Because we're already seeing the temperature drop lately, and also temperature leveling. And the temperature drop again, right? Let's do this stuff. Okay, so this will be your cooling curve for pure menthol. You're gonna do the same thing with solution, with the menthol as a solvent, and also I'm assuming that you're gonna do this couple trials to make sure that your data is reliable. And that's how you're gonna do your experiment. And before you throw away your waste, you melt them again and dump this menthol waste, which is a liquid menthol, into your waste container. And the tube, you don't have to wash it, which is a good thing, and dump into the glassware waste container. If you don't know where that at, ask your team. Alright, thank you for watching, and I hope you guys have fun, and good luck.